EMF equation of an alternator. EMF equation of an alternator. Phi is equal to useful flux per pole in Weber. F is equal to frequency of induced EMF in Hertz. We know that alternator consists of two parts, stator and rotor. Stator consists of armature winding and rotor consists of field winding. When field winding is fed from DC supply, it can create a flux. That flux cuts the armature winding. After passing the air gap, it cuts the armature winding and EMF is induced in the armature. The magnitude of that EMF can be found out with the help of this derivation. We can find out the magnitude of induced EMF with the help of this derivation. EMF equation of an alternator. Phi is equal to useful flux per pole in Weber. Phi is equal to useful flux per pole in Weber. F is equal to frequency of induced EMF in Hertz. P is equal to number of poles. Z is equal to number of conductors. Z is equal to number of conductors. T is equal to number of turns per phase is equal to Z by 2. So two conductors constitute one turn. So one turn T is equal to Z by 2. N is equal to speed in RPM. N is equal to speed in RPM. Kp or Kc is equal to coil span factor or pitch factor. Kp or Kc is equal to coil span factor or pitch factor. Kd is equal to distribution factor. Kd is equal to distribution factor. Total flux cut by each stator conductor is 5p Weber. Total flux cut by a conductor is equal to 5p Weber. The time for one revolution is equal to 60 by n. That means it rotates at n rpm. N rpm means revolution per minute. N rpm means revolution per minute. That means time for n revolution. Time for n revolution is equal to 1 minute. That means n revolution takes place in 1 minute. So time for n revolution is equal to 1 minute is equal to 60 seconds. So time for one revolution is equal to 60 by n. The machine is rotating at n rpm means the machine makes n revolutions per minute. The machine makes capital N revolutions per minute. That means time for n revolutions is equal to 1 minute is equal to 60 seconds. Time for n revolutions is equal to 1 minute is equal to 60 seconds. So time for one revolution is equal to 60 divided by n. Then average EMF induced per conductor is equal to rate of change of flux linkage, that is d phi by dt. Average EMF induced per conductor is equal to rate of change of flux linkage is equal to d phi by dt. Rate of change of flux linkage. d phi means 5p Weber. Total flux cut by a conductor is equal to 5p because flux produced by one pole is equal to 5. How many poles are there? P poles. So total flux cut by a conductor is equal to 5p Weber. Time taken for one revolution is equal to 60 by n. So rate of change of flux linkage is equal to d phi by dt is equal to 5p divided by 60 by n is equal to 5pn by 60 volts. Average EMF induced per conductor is equal to 5pn by 60 volt. The rotational speed of the alternator is given by n is equal to 120 f by p because this is an alternator whose speed is n is equal to 120 f by p. Whose speed is n is equal to 120 f by p. Average EMF induced per conductor is equal to 5pn by 60. 5p divided by 16 is equal to 5pn by 60. So substituting the value of n in the average EMF induced, that is 5pn by 60 n in 120 f by p in substitute because this is an alternator or synchronous generator. It runs at synchronous speed. So average EMF induced per conductor is equal to 5pn by 60, that is 5p by 60 into 120 f by p. 5p by 60 into 120 f by p is equal to 60 120 so 2 times pm cancel 2f5 volt. Average EMF induced per conductor is equal to 2f5 volt. Okay, if there so this is average EMF induced per conductor in one pole. So how many average EMF induced per conductor, that means in one conductor, average EMF induced per conductor means average EMF induced in one conductor. How many conductors are there? Set conductors. So average induced EMF per phase, there are set conductors per phase. Therefore average induced EMF per phase is equal to 2f5 into Z. Average induced EMF per phase is equal to 2f5 into Z is equal to 2f5 into Z is equal to 2t. So 2f5 into 2t is equal to 4f5t. 2f5 into 2t is equal to 4f5t. Then RMS value of EMF per phase. RMS value of EMF per phase is equal to 1.11 into average value. RMS value is equal to 1.11 into average value is equal to 1.11 into 4f5t is equal to 4.44 f5t volt. 4.44 f5t volt. So RMS value of EMF per phase is equal to 4.44 f5t volt. Okay, we have to consider the short pitch and distributed winding. By considering these two factors, EMF per phase is equal to 4.44 f5t into Kc Kd volt. Kc means coil span factor, Kd means distribution factor. By considering these two factors, we can write EMF per phase is equal to 4.44 f5t into Kc Kd volt. 4.44 f5t into Kc Kd volt. So this is the voltage regulation. This is the voltage EMF equation. This is the EMF equation of an alternator. This is the EMF equation of an alternator.